Okay, hello everyone. Wait a minute, I'm not seeing what I'm expecting to see here. Oh dear, hold on 1 second. Well, hello to people joining the live stream. We are doing a Wolfram language design review, part of our incremental language development program, and we have a variety of different topics to talk about today. And hopefully I can set this up so I can actually see what I need to see. Okay, good. All right, first item, styling elements in grid. Yeah, this is one of our most kind of bizarre programming, laparoscopic programming kinds of activities. In my view, the whole way that we specify. Right, so you're saying, okay, so the question is, if I want to put a divider in here, how do I put dividers and then style the dividers?
The dividers option, and I'm not remembering off the top of my head how styling is done. I'm looking that up.
I think it uses the same sort of notation that background does.
Right, yeah, which is very hard to understand.
Yeah, the styling is in the specification of the dividers option.
Okay, the problem that we have is that, I mean, this whole business about 3 goes to red, 2 goes to light blue. Oh my gosh. See, this is a column specification, I guess.
Yeah.
That's a row in that order.
Yeah, if there were more than one column specification, then that would have had to have been a sublist.
I hate variables like t. It's going to mess up my whole session here. Okay, so let's look at this. So you're saying here, well, I mean, what would happen if I'd said 3 or 1?
That's not going to work.
For reasons unknown. Okay, because let me explain something. In graphs,
I mean, is this really idiomatic?
Okay, so listen. We've got a number of patterns that are sort of similar, okay? So for example, in graphs with vertex style, it does accept patterns like this. See what I'm saying? The way vertex style works, and I think there are people here who know it and use it frequently, you give it a list of patterns of the form vertex name goes to style. Okay. And I think that idea of specification goes to styling, that's a possible idea for how to do these in general. If that makes sense.
Which would start with a naming convention other than positional.
Well, it might do, yes. But I mean, I think that the problem that we have here is, whenever I want to, okay, so here's a typical thing I want to do. I've got a grid. I want to style the top row with a different background. I want to put a separator between the top row and the subsequent rows, but it's super hard to do that. And I wind up going and looking at examples of other grids that have similar things done to them. Am I making sense? So what I'm asking for is, can we invent a way of making
Well, so there are 2 sorts of ways that one might go about solving this problem. One is to do what you're suggesting, which is language extensions, and the other is to make an interface that just allows you to set the specification the way you want, and then, if you need it back in language form, have some way to
I
to
understand.
extract it. And I worry about the language extension because I already receive complaints that people don't know how it works at present even.
Oh no, they absolutely don't, and I don't. I could say I don't.
And adding more features doesn't.
Well, I think it was just not very well
that
designed.
would simplify it.
No, I agree. But what I think is there right now is very hard to use. And I mean, it is along with look.
I wouldn't say.
Yeah, go ahead.
I wouldn't say it's hard to use. It's a little bit inconvenient. I would rather have the dividers, as you mentioned, and the background locally available, rather than, like, often the grids I make are tens of thousands of rows, and I always have to write a little program that determines which one what to add in the background options.
That's horrifying. Yes. I mean, and some of this stuff, it's just really hard. I mean, okay, look, I don't even know here. I don't know if I have X rows, Y rows. Okay, so look, there are three approaches I can imagine. One is scaffolding to make it easier for people to write correct things by prompting them, essentially with autocompletes. That's one possibility.
Mm-hmm.
Another possibility is a tool like we have for images. I have a feeling people will not be happy with that because.
So,
go ahead.
Well, and a fundamental problem is that everything is based on counting. This is what Lou was hinting at. That what happens, if you really wanted to mark the content of the fifth row, but then you add a row above it, and now you have to change all the references to 5 to 6.
Yeah, right.
And this is very much a real problem. That massive table that describes precedences, for example, in the documentation. That's really horrible to maintain because it does exactly that.
Right. Let's see. Right, I agree. So, I mean, having it be local is much better. Having it be a wrapper like this item wrapper is a much better idea. Now, the other thing is, there are some, we could imagine themes for grids. That would also be a possibility, but I'm not sure. I mean, in the things I've done, there's just so many stupid fiddly things. Look, I think this needs a kind of another look at the design. I think we need to think about, if we were doing it from scratch today, what would we do?
Well, we do have, and I'm not prepared to demonstrate this, but we do have some, a non-trivial attempt at a user interface for for inspecting and modifying grid attributes.
When was that built?
It was kind of a background project over the past couple of years.
Okay.
But we've been working on iterating enough to, we didn't want to bring a version that was too raw and premature to you. It's, you would have just ripped it apart with all the same criticisms we would have had.
Fine.
So
okay, let's just look here. I mean, the other thing that we could do, which is an even much more straightforward thing, is a pure documentation play to begin with. That is just a giant gallery of examples. which we surely have, even from things I've done. You could pick up a lot of examples. See what I'm saying? So in other words, there are tables where the top row is differently colored. There are tables where there are, where there's a border that's different from the internal separators. There's tables where there's separators from the first row, but not subsequent rows, et cetera, et cetera, et cetera. Am I making sense?
Mm-hmm.
Maybe what we should do is try and collect
that
such
was exactly what I was looking for the other day, just to comment. It's probably a very common sort of thing for users to try to do, just get these examples from the documentation.
Right. And the documentation is kind of lame in this regard. Because the documentation is very, we've got this function and that, that functional thing, rather than here is a picture of a grid that looks roughly like this.
Yeah, I had endless trouble figuring out frames and dividers myself.
Yeah, well, so
and background coloring was also not easy. Having a lot of examples, if we can't explain it clearly in words, then having a lot of examples will help. I mean, if we could explain it better, that would also help.
Right, but so what we could do, I think is basically to have a guide page, and possibly even we could have a style of documentation in which we link to the guide page from here. Right, that's what we do in for example, formats. Import, for example, does that. People know what I'm talking about.
Yeah,
Import.
but I'm not sure how you're suggesting applying it in this context.
Okay, so what I'm suggesting is that what it does is it says gallery of grid options or something right here.
Okay.
And then that goes to a guide page that is just filled with different sizes and shapes of grids. Now, I admit that that's not quite. Now, let's see. What will we do then? We then have to link that to the code for each one of those things. I'm not sure. That requires another design for how to do that. Possibly they could be click to copy. I'm not sure. Is that obviously wrong? Because if you do click to copy there, click to copy and the code is a grid of an iconized generator here of something rather straightforward like this. And then what you would do, the workflow that you would use is you click to copy the thing, you put it in a notebook, you see what it does, and then you start tinkering with it. Am I making sense?
It's like examples, but not examples. Do we
want
to abandon the example model here?
I don't think it's working for this. And the reason is that the examples here are very sequential in sections and so on.
But we could link to them. We could have a guide page like like you're suggesting, with links to specific examples.
Yeah, we should do that. That's a fine thing to do. But I think it should also have a click to copy of some kind so that you can just use it directly from the guide page. Am I making sense? Because normally on a guide page, the only thing that's there as anchors is function names. So the typical workflow is you click that, you go to the function page, and you use the function from the function page. This is a documentation issue, but
yeah, I was just going to say, I can sketch out the content for such a guide page, but I'm not going to create.
No, we have to separately
the kind of visual styling and all.
I know, so we should talk to Brian separately about that. Okay, but I think the first thing we need to do, and it's also possible that these documentation pages are just bad. That they were written when grid was much simpler and they got added to and they didn't get rebalanced.
No, that's it. Actually, they weren't written. Grid has never been much simpler than it is today. It's always been about this complicated.
Maybe this page just wasn't written. Maybe it's just bad. Because that's having 6 examples for styling is just not enough. I've looked at these examples before. It's just not enough.
I agree with that.
Right now, maybe if there were 8 pages of examples and I could just scroll through it and I could see the one I want.
Yeah, and of course, this comes down to the other problem is, if you had 60 examples, just a long stream of 60 examples you have to scroll through also has its own presentation issues.
Yeah, I think you'd want subheadings, that open, John, so that you could have examples that emphasize framing or background, etc.
Possibly, yes. I mean, just having one that's called styling doesn't really cut it. It's just not right. It's just the wrong thing. And there's spanning elements. Well, we've got one on spanning elements, but I cannot believe that 3 examples of spanning elements is enough.
Actually, I mean, in the case of spanning, I think it is.
Yeah, actually, maybe it is. I'm looking at these and they look reasonable. Well, span from above, span from both. All right, that one doesn't look bad. Look, I think the killers are background, which is just frigging incomprehensible. And like this one where I want it to be pink and then yellow. How do I do that? Do you understand what I'm saying? I want the first column pink and the other columns yellow. How do I do it?
Yeah. You would, after the pink, you would add yellow and curly braces.
Not like that, though.
No, the one below is repeating pink and yellow. You want a single, no, that's wrong. You want a single pink and repeating yellow. So
okay, so wait a minute. So if I say this,
so after the pink, comma, yeah, there you go. That's what you.
And then I want to end with a red.
Right. Yes, that would be the way to do it.
That's magnificent. If you give me an example of that, I'm off and running. Honestly, just adding that example would right there help a lot. I mean, maybe the problem we have, number one problem we have, is just bad examples or not enough examples. Right? Like this would have helped me, right there, that example would have helped me. Am I making sense? Mm-hmm. I mean, in fact, if we went this, if we did this, I will get it from that example what to do. You see what I'm saying?
Mm-hmm.
And I mean, I think we need that example. We need another example that goes up above here, that goes, that allows us to have, gray, let's say, up at the top. Oops. What did I just do wrong? Oh, I need another close there. Is that right? No, that's wrong. That's not what I wanted.
Well, yeah, that's repeating gray. So if you want just a single gray, yeah, there you go.
Okay. So but that again, this is going to help me because this example would tell me what to do. We just had too few examples here. Let's start up by adding some examples. Make sense? I mean, that's a super easy thing to do.
Yeah.
We should be able to get that in really soon. And can somebody can I just send these? Who can I send these to?
Well, me, probably.
You add it to the agenda. I can send it over to John.
Well, where am I saving this agenda?
It should save to Dropbox.
It should save itself to Dropbox. No, it doesn't. It doesn't have a hope. What are you saying? It should be saved to Dropbox, or it should save itself to Dropbox?
Save to Dropbox. Yeah, just hit
save.
save.
So it's already there.
Yeah, hit replace. Yep.
Okay, we need a slightly better workflow for that, but that's not a big deal. Okay. All right, so let's now just talk for a second. Okay, so this helps me. I mean, I probably didn't even know this, or I did know it once, but whatever. Mm-hmm. Right? Okay, so now let's say that I want the top row Okay. I want to, there's nothing about dividers here. There's nothing in this table about dividers. There's no information here about dividers. Well, frames and grid lines, okay. Is that dividers?
A frame is like
no,
the same thing. Oh, there is dividers there.
Frames are a subset of dividers.
Okay, so here's what I want. I want to know, a real thing that I want to know, as opposed to some toy, is I want a different kind of divider underneath the top row than in the other pieces, right? So let's imagine that I want some, I'm going to say, but let me get rid of all of this, no background, because I can see that they're factored. I say frame arrow all, okay? And I know what that does, okay? Now I want that top row to have a different frame underneath it. I want that line to be different. How do I do it?
For just the line, actually, instead of frame, I would probably use dividers. Let's see, I think it would be dividers arrow, dividers arrow, list of all, comma, let's see, well, I can think of a way to do it using the repeating syntax.
If I might say so, guys, we already lost the game here.
I agree with that.
But it's a it's a deeply non-trivial specification. I mean, you have to understand that there's so many directions you can go here.
I know.
I mean, you could say you want all the lines except the one under the third X in the first row. No. This is where we have to do a little bit of a reality check. Okay, I know from things I've done. Right, a very typical thing is you're labeling the top row. You're labeling maybe the first two rows, but you're saying what the columns are, right? And so you want a different styling for the top row, or you're labeling what the rows are. You want a different styling for the left column. Okay, even on our live stream suggests that. What's that?
Those are both things I wanted to do the other day and couldn't figure out, the labeling.
Right.
Vertical and horizontal.
Yeah, right. So those are very common things. And it's possible that we should have, named options for those things, but let's cross that bridge later.
But in this case, the specification would be, if I recall correctly, so after the all, comma, open a list, and then true, comma, false, comma, sublist of true.
John, I'd like to make two suggestions, if I may. One is if you could come up with a clear description of what that language means, this true, false, etc., in terms of layout, that might be very useful.
I mean, it is in the details section, but
it was hard to figure.
This isn't what I wanted. This isn't what I wanted. What I want is I want a thick line there, for example.
Okay. Well, then you can replace the false with, absolute thickness of 5 or something.
The other thing I want to say is more of a question is, does grid support the way graphics, two-dimensional graphics does, or 3D even, labeling that is outside of the grid itself, but nonetheless useful for vertical or horizontal axes?
No, it doesn't.
No.
It would be good if it did. That was something.
Could it use the same syntax?
Hmm?
Could it use the same syntax? I mean, okay, so another thing would be tool call-outs and things in a grid. But look, just nailing this stuff would already be very helpful.
Yes, I agree with that.
We already have all these capabilities. Okay, so listen, I think, and I'm not sure who should be doing this, but it should definitely not be John. Okay, we need to inventory. It's possible one of the maybe somebody in the special projects intern crowd could do this. The inventory, both, for example, in things I've written and in other community posts, things like this, types of, just look through for the structures of grids people have produced, and then look at what the code looks like. Because I think Danny and I both are agreeing that we need to do these kinds of things. So another thing I'd like to do is to change the styling of the top row. How do I do that?
So and there are about 7 or 8 options that follow basically the same pattern here.
Okay.
And
how do I change the styling? Okay, let me ask this question.
It's item style. It's
okay. So if I say false here, by the way, that will do that. Okay, good.
Yeah.
Okay, so then I say item style.
Do item style and background have essentially the same syntax then, John?
Yes.
Okay, good.
Yes. The tricky part about item style is if you're wanting to combine multiple styles. I forget, is it just directive or you have to put it in a sublist? That's the thing that I don't remember and haven't tried to do for a long time. But if it's just a simple, a singular style directive, then it's pretty straightforward.
Okay, listen. I think what we need to do, let us inventory, things we've written. I think it'll be good to look and see if there are any style guides out there for like academic journals, things like that, for tables. It would also be useful to look at, for example, in spreadsheets and things like this, whether there are standard formatting schemes for tables. Let's do that and try and make a much larger list of examples that can be given here. Okay?
And by the way, I just want to be clear. I'm conceding your request for examples, but in terms of the narrative description, I think the narrative description, it's necessarily complex because the specification is complex.
I know.
The narrative description does its best to do this.
Look, I've tried to read it a bunch of times. I've had a very hard time reading this.
So what I just showed you is a combination of the spec X, spec Y.
I know.
The table,
I understand what it is.
Yeah, and then one of the specifications down below.
Right. I understand what it is. Okay, it doesn't help me in practice. Yes, I can puzzle through it eventually, although it's much easier for me to find another example where I've done something similar. And the examples are awful here. So, let's just, we can save ourselves a lot of coding work by just cleaning these up and seeing whether that's enough.
That would help a lot. I agree that I understand what John's saying, that this is very hard to document carefully, fully, and accurately. And
I don't think I think the legalistic documentation is not the most important thing here. I think we just need examples. What is this?
I will say, if the documentation can be simplified on these matters, and maybe it's just not possible to make it both simple and complete and correct. I don't know.
I think it's not terrible, as John says. I think what's missing is good examples.
Okay.
And lots of them. Now, Ethan is commenting on live stream about grid themes. I'm a little bit unconvinced. Okay, I do not think that graphics themes have been as successful as I might have hoped. That is, I tend to use the default, and I've never really gone through and sometimes I've used weird ones, like for example, people were using for ages the some style sheet that was intended for some very weird purpose that just happened to look kind of nice. It reminds me of a lot of these things.
You're thinking like pastel or something like that?
Yeah, it was something like that, but it was something more obscure than that, I think. But it was, I have this bad feeling that people don't, sometimes people will find a particular, option setting, particular theme that they like, and they'll just stick with it, and that's fine. But people going and exploring the theme collection, I don't know. What do other people think about this? I found, for example, when I've tried to look at material surfaces for 3D graphics, a few times I've looked there at the galleries that we have and picked one out. What do other people think about these gallery-based approaches to different types of looks for things like this. Anybody want to comment on that? Nobody here is relevant to that?
You know, in general, I think the idea of themes is, something that I support. In the case of tables, it may be that, I wonder if we want to do, just fixed themes or themes with parameters.
Well, we've got the idea of themes. Yeah, okay, that's a different thing. That's a more keyword-based way of setting the things that we are describing as completely obscure to set here. However, in the end, the syntax that we have is not completely stupid. It's just very hard to remember and see what to do in a particular case. But once you've got a case like this, given this, I can trivially modify this to the thing I actually want. Do you get what I'm saying?
Yeah.
I put a link to a WFR that many people in the alpha world like to use.
I'm not seeing that link, Michael. I don't know.
Oh, sorry. It was just to Ian. I had to the wrong one. To everyone.
Okay, that's an amusing idea from Ethan on our live stream. That is an interesting idea. A neural net that can take a picture of a table and generate the style specifications. That's an amusing idea and probably not undoable. We should look at that. That's an interesting idea. At the very least, that can be a project for this year's summer school. Somebody can try and make a prototype of that. Good idea. Can somebody make a note of that, or should I do it? Oh, I'm doing it because nobody else said anything. Anybody here? Who's project managing here?
I have it in my notes.
I'll do it myself right now. That's a good idea. But I mean, I also, okay, we need to figure out, and perhaps not, we don't know from this meeting who can do this. As I said, we need to make sure that somebody goes and looks at standard style guidelines for grids and tables and comes up with a big, long inventory of things that we need to be able to support.
Did you take a look at Michael's link yet? I mean,
no, I didn't. I don't have Michael's link. So
no, he put it in the chat.
It's a nice function, and it references another one by Michael Salami that's also pretty good.
To me, it looks like basically, this is a theme. This is one theme bound up in a function. Is how I would characterize it.
Okay, what does this do?
It has column and row headers, and it delineates for readability, the background row color.
It also has that nice capability of dealing with missing. If you look at the the upper left corner, in cases when it's missing, that's a good thing to have. Maybe we already have that. I don't know.
No, we don't. Okay, look. We've got several steps here. Inventory tables that we want. Make more examples. Then let's see if there is a new design for an enhancement to grid. For example, we could imagine a headers option to grid. Do you understand what I'm saying?
I understand what you're saying. I'm not ready to comment on it yet.
Nor am I, right? But I'm saying that's an alternative, but we may be able to solve this just with better examples. Am I making sense? Do I have to say this? I mean, yeah, we know what we need to do, but we need to figure out who is going to do this, because it isn't you, John.
Well, I don't have an immediate good answer. That's
I
not
know.
me.
I already told you several answers, so I'm expecting that project management is going to follow up on this and figure out, if necessary, bringing it, to the right place to have these resources found. Okay, does that make sense?
Yep.
Okay.
Makes sense to me.
Okay. You can ask Brady for his suggestions, but I'm suggesting, I think there's several people who are possibilities. Right.
Well, and
Okay.
it should be said, I mean, there's a certain pattern here. If you start off with, whichever option, background, the pattern for the other options is going to look a lot like the pattern for background.
Maybe not, because it could be that the things you want, for background, right? The first row, the last row, those kinds of things, a particular row in the middle, right? How do you, I mean, another thing we need is referencing, backgrounding a particular row. Like, I believe there's an option here. If I say background arrow, none, comma, gray, like this, okay? And now I just want the fifth column. Is there not yet another thing here which allows me to say?
It's still in the first argument. The
Really?
5 arrow.
Okay, so then I go here, 5 arrow red. Okay, great. That's fine. Just show me this example, and we're in good shape here. See what I'm saying? Then I have some fighting chance of knowing what the heck to do. I mean, and actually, you've got to show me one more thing, which is you've got to show me what to do if I've got 5 comma red, 7 comma green. I assume I can do this. Yes, I can. How nice. Why did the gray not go on top of those?
I don't know.
What would happen if you put it first? Would it matter?
I can't put it first. I can't put it first because it's representing row specifications. What I might be able to do is to say none and then 1 arrow gray. Okay, so I don't know why that's happening.
Might be the intensity of colors if you used light red.
No.
Okay.
No.
So it's just a question of who wins the conflict.
No. It's I think what it's doing is it's only combining the colors from the non-rule specification, and then the rule specifications just overlay or sorry, overwrite, I should say.
Okay, I'm going to predict that in this case, let's see, I'm going to do none, comma, and that will repeat the reds. Is that correct?
Correct.
Oh.
You have an extra level of list.
Really?
Around the whole thing.
Yeah, I thought it would do this. So basically, the specific sparse array type syntax wins, which is okay. That's a perfectly
that's just another way of saying what I said.
Yeah, that's a perfectly reasonable thing to have happen. But again, it's got to have examples, right? Examples, so people have a fighting chance to understand this.
Is there a like a 1,1 list specification to get?
That would be the third argument. First argument is column. Second argument, first member of the list is column. Second member of the list is rows, and then the third member of the list is the item. Element specification. Yeah.
Got it. Okay.
That's beautiful. Now we're all learning, but we got to have examples, right? Totally inadequate set of examples. Okay. If really nobody else can do this, I will generate a bunch of examples. This is not difficult. It's just, and also they have to be done not too mechanically, but just showing off all the different sort of orthogonal things that you need. Make sense?
Mm-hmm.
Yeah.
Okay. Let's move on to the next item, please. Okay, so I think we've got some action here, mostly add examples, find standard types of table layouts, make sure those are in the examples. Once we see all those standard table layouts and see the examples, maybe decide that we can do better with the design. Makes sense? Okay, onward. Proof graph design.
So this is based on the updated version of Proofgraph that Nick M had done. And then we have Billy here from design who did a few mock-ups for what that should ultimately look like.
Okay. And also I gather that Nick has now found the patch that's needed in the underlying FindEquationalProof code, C code, to allow proof functions to work correctly. Is that a true statement, Nick?
Well, that will certainly help. Yeah.
Okay. And did you give that to Adam, and did you get feedback from Adam that he can handle it?
Yeah, it's already pushed, I think.
Oh, great. So it's ready for 13.1.
Yeah, it's the very small patch that doesn't break anything. And I already have a prototype of a new proof function that using it.
Does the proof function have basically the same stuff inside it, or does the proof function use different proof operations?
Yeah.
I mean, Jonathan's proof function uses map at of replace. Is that right?
Yeah, it's the same kind of thing. There's a bunch of unnecessary pattern substitutions, like renaming of variables in there, and substitution critical pair lemmas are also working. Okay.
The good news about that is that after a decade of that project not being done, Jonathan went and did it. So but now it is, to iterate on it is not surprising at this point. Okay, all right. So what we're doing here is we're looking at the nicer colors and things invented for the mathematics project and applying them to FindEquationalProof, right? Is that correct, guys? Hello?
Yep, that's my understanding. Billy, maybe if there's more specific.
Billy, can you
details.
speak up, please?
Yeah, that was also my understanding as well, how the metamath relates to this.
Okay, so I don't understand what, I mean, what we need is the FindEquationalProof proof object. And this is a recoloring of that. We are going to have to provide the legacy one because people are going to want to still use it. Am I making sense?
Yes. And that's the dashed one all the way to the side in the mock-up, the sort of legacy one. Just for
that one there.
reference. Yeah.
Okay. So the main differences here are, I mean, what are the different? Okay, wait. Was this done by somebody who actually knows what these things mean, or is this just pure design?
Pure design.
Pure design, yeah.
Oh, sigh. Okay. Okay. So we have in mind then. Okay, so Nick, you need to. So the question is to make less saturated colors. Is that the idea here? Was that what's being done? I don't understand. What's happening here? Can somebody explain, please?
For a dotted style to represent the dashes as it would appear in this new MetaMath style.
I'm totally confused. I'm sorry. I'm totally confused. Okay. Right now, okay, first of all, there are more nodes here. This is just showing what we would now call the events and not the tokens. Is that true? Nick, Jonathan, please. What can somebody explain what's going on?
Well, with what exactly? What was the question?
Okay, the question is, we've got proof graphs. Okay,
right.
We've got the new proposed version of proof graphs. What is the difference between them, other than colors being changed? My understanding is
an addition of events, explicit events,
or and explicit tokens, right? These are these tokens or are these events?
Well, they kind of both, but more.
Okay, what is it that we want? I mean, these graphs are nice in their own right. Can we please go through what are those graphs supposed to be? Okay, does anybody here know what's going on with this? Because if they don't, we can't have this discussion. Can somebody explain to me, what is the relationship between this graph and this graph? What are we trying to change? What's the story here?
Well, the simple variation is that you just add events there and explicit ones. So it's just a bunch of additional vertices there and the new styles.
Right.
So
okay.
That's
okay.
changed.
So there are two different things we want to do. We want to restyle the previous one to use nicer colors and conceivably change slightly the, what we're doing here. Okay. What's dotted, what's dashed, etc. Okay. That's one thing. The second thing is we want a style in which we include the tokens as well as the events. Is that right?
Right.
Okay. So let's start off with the question. All right. And then we also have this version here in which we are giving the explicit theorems generated at each stage. Correct?
Yeah, just the same thing, just with an explicit box.
I understand, but we have a very specific problem, which is that, right now we have proof graph, which is one of the elements here for a proof object, right? What we're proposing here, and that proof graph for compatibility better be something consistent with this thing here. Am I making sense? Then we need things for these as well, right?
Yeah, well, just an additional property.
Yeah, I know, but do we need 3 additional properties, or what do we need here?
I guess one is enough. And maybe
no, but we don't need one because we've got this case here in which we are not showing events explicitly. Do we want that case or do we not want that case?
We show them, they're just tiny.
Okay, but then we need some way of distinguishing between this case and this case. Right? How are we going to distinguish between this case and this case? No, we could have some graphics.
Why do we want?
What's that?
Why do we want to distinguish them? It's just
because we've got to say which one you want. Which one do you want?
But this is just graph options, right?
But which graph option?
Like a vertex size for event or something.
But we can't give that because we don't have, unless we have a convention, unless we document what the names of the nodes are so that you can use the vertex styling functions to determine the vertex style. We don't know how to do this, right? So we could, I don't know what the conventions are for the actual names of the nodes in a case like this. Jonathan must know what they are if he remembers.
Right, but they're just tagged with expression information. And with the events, I don't know at all. It's still unclear to me why it's worth including events. But
okay, but the thing is, in this case, what is the structure of a critical pair lemma, for example? Does it have a particular?
The node will just be called critical pair lemma whatever.
Okay, so if you gave a pattern for what you would say is vertex style arrow and then the pattern critical pair lemma comma blank arrow whatever, is that correct or not?
Yes, you could restyle that way.
Okay, I'm sure we didn't document that, but that would potentially work. Okay, so look, what we're going to need, okay, we're not going to do this in this meeting. Okay, I think we need, Nick, Jonathan, Billy, to figure out, what we're trying to get is something that has, so none of these stylings are Jonathan's original version of how this works, right? These are both different because Jonathan's version has these things which are kind of, which is different from this again, right? Because in this lemma here, in this substitution lemma, you've got a lemma, a theorem from here and a theorem from here are being combined, and that node there represents the result of combining this and this, correct?
Yes,
right. Listen, if we can't say anything, we got to move on to the next item. Okay, can you guys please try and iterate this and come back, because we would really like to get these changes in.
But again, like I can't comment on this because it's still unclear why we're doing it, right? So the reason we didn't include, substitution event information in the original design of this is because it doesn't add any additional information. It makes the graph more complicated, and everything that you could have got from including the events, you could reconstruct anyway. So it's unclear if there's some reason to include the events. I would like to know if it's just to gain essentially conceptual compatibility with token event graphs, then it seems like it should be an option, an optional property rather than a complete redesign.
I agree.
It's not a complete redesign, right? It just would be an additional property.
Yes.
Right.
I mean, look, it is for expository purposes, Jonathan. You are right that they're unnecessary, right?
Right. Okay. But in that case, I'm going to advocate for the proof graph returning the minimal structure necessary to represent.
I think you're right. Okay. I just think that the new colors and things look nicer than these ones. Sure. And, that's all it really comes down to. And but we want to have the option to produce these better, these things which for small proof graphs are expositorily useful. Right. And this case also is expositorily useful for very small proof graphs. Make sense?
Sure. By the way, is there a particular reason why we removed the shape differences between substitution and critical pair lemmas?
There was for the metamathematics post, but whether that's a correct thing for what we present by default, I'm not at all sure. I think.
Actually, same with the conclusions. It occurs to me.
Where's the conclusion?
We chose the tombstone symbol for the conclusion and the triangle symbol for the critical pair lemma. I remember us having design discussions about what the right symbols were, and they.
Yeah, no, I remember that too. And we, the criteria here were a little different. The criteria here had to do with a particular exposition that was making analogies with the physics project. The physics project had not been invented when we invented, proof graphs. So, look, there's one level of this, which is pure color changes and changes in the coarseness of the dashing and stuff like this, which are pretty trivial. And perhaps for this version, that's what we should do. That's all we should do. Am I making sense? Anybody? Okay, we got to move on. Let's go on to the next item. Okay, so you guys need to come back. And Nick, could you please try and wrangle this and get these folk to other Nick with a C.
Yeah, other Nick. Yep, we'll have a talk about it and try and get a more concrete follow-up. This was something that was on ice for a little bit and needs to be taught back. So you can look at this one. This is an outgrowth of a prior discussion about looking at our pure math package and looking at what might be useful. This is kind of related in terms of having a graph or network of related items in our topology here, since it was kind of visually similar and along the same lines as what the last.
So what's the question here?
So we're basically trying to inventory the pure math package and see what might be useful as something to extract, or there's a whole realm of set theory applications that is a little more in depth that we'll look at as kind of its own item, but this was something that was kind of similar to.
Okay, what do we expect? Okay, so this is a representation of mathematical knowledge, and which Michael maybe can speak to, or if Ian, I think, could speak to.
Yeah. So one of the entity types that we were curating was topological spaces, like particular named topological spaces. Yep. And we also wanted to know, basically, for every single one of these properties, is it true or false? And so down below, there was this large list of axioms that we also curated that you can use, like given some starting set of assumptions about a topological space. So this is showing all the consequences of being a manifold here.
Okay.
So you see in the text box, it says is manifold. And so
Yeah,
everything that's green is something that's implied by being a manifold. Everything that's red is everything you know is false because it's a manifold. And
Cool.
we're deducing these from these axioms, but it was kind of a bespoke implementation that James Molnix and I put together. I'm not sure that it actually is complete, but the key interesting thing is for that, it became difficult to curate these topological spaces because it's just kind of difficult to work with this graphically. And I don't want programmatic tools to say things like, what is the next property that's like gives the most information? Because I had to check each one of these basically on paper, write a proof myself and be like, yep, I checked that this is true.
Okay, so I've got
you want to go through here and basically
I got two comments about this. There are two types of, at least two kinds of things that we're doing that are related to this. One is Jonathan's efforts in category theory. Another is the whole Sparkle query system.
Mm-hmm. Mm-hmm.
And I would like to understand, and is there anything else that is sort of related to this? I mean, this is a set of, how should we think about this?
It's potentially related to what Nick is working on with multi.
Yes, it is also potentially related.
Like multi might be a good, like if I could use multi to simplify the code for this.
Well, you're saying you might be able to write this graph symbolically with a bunch of multis.
Right. So this graph is actually not showing all of the information about the axioms. This is showing just the direct implications that can be deduced from the axioms.
So it's, you mean there's a transitive closure of this graph that's...
Yeah, so can you click the hide deduced button? So there's now new equivalences because you had all of these trues and falses for different properties. So new things became equivalent. New, now there's loops, there's new implications. So the graph you see is not a complete representation of the axioms. And you also can't necessarily tell which axioms.
In what sense are there axioms here? I mean, these are
Scroll to the list underneath this. There I have a column of all of the axioms that we curated.
Tell me an example of an axiom here.
Is connected implies it's not disconnected.
Oh, I see. That's considered an axiom.
Yes.
Can somebody, maybe Jonathan, say how this relates to category theory, if it does?
Well, I mean, I think actually Ian brought up this point in a previous CT discussion, but like a lot of the stuff with the curated topological spaces data could in principle be reformulated in abstract category, right? So, something like, the property is homeomorphism or something can be reformulated in terms of is isomorphism in the category top, and we can construct some abstract representation of top. So if nothing else, abstract category and its related functions would give you a new data structure to represent things like this, and also to do computations that let you figure out deductions and stuff.
Mm-hmm. So I also want to say this is like at a coarser grained look. So we're not necessarily trying to prove that, for example, biconnected implies arc connected from like the machinery of topology. I just take that as a given, and what I'm trying to do is for a particular topological space, classify which properties holds for this space. And I'm using this graph interactively to try to deduce that.
It's kind of like an effective field theory.
Yes. Well, it's kind of interesting with respect to, and we should have asked James to join us here because he's been working on the mathematics stuff. I would say this was, yeah. Okay, look, there's also, these formalized math systems like MetaMath and Lean and so on that we have been trying to understand how they relate to what we're doing, if they do. So, we've got these different things that are swirling around. We've also got, I don't know how this relates to the hierarchical entities project and how that then relates to the Sparkle stuff.
If you look at the axioms, I think that a lot of them are directly translatable into representations in Sparkle, like ands become like class intersections.
Okay, but how does that relate to in other words, in our hierarchical entity, is an astronaut implies is a person? No, actually, it's not true. There are dog astronauts, but one could imagine that it was true.
And I also want to be able to say, like, this class, if you're in this, if and only if, like you might have a conjunction, like an and of an or on one side of an equivalence,
Right, but so this is a way you're effectively saying, these are various set relations of various kinds.
Also, unfortunately, a lot of these properties depend on the exact cardinality of the set in the case of finite sets. And Sparkle has some representations for cardinality that this tool just completely can't handle.
Wait a minute. So cardinality, we're talking. Okay,
you see the drop-down menu that says all?
Yeah.
Can you click that and select cardinality?
Can I now?
Click reset. So these are the cardinality properties we have, and degenerate means exactly one, but we don't have the ability to say exactly 4 and take into account things that we know that may only hold for,
I don't understand this at all. I'm sorry, I don't understand this at all. What? Okay. There's a class of questions that we confront with hierarchical entities, which are representations of facts about the world that are these kind of set theoretic facts about the world. All
people are human beings, so they could inherit species data properties, which could have properties from
right.
So
these are
ontology project.
Right. So these are set theoretic relations effectively. And we need to use some of these things for purposes of, one place we need these is in our hierarchical entities project. It is remarkable how long it's taken for us to really need these things. That is, the vast majority of entity computations don't involve that kind of inclusion type stuff. It's very reminiscent of units. We went for years, and spreadsheet programs don't have units typically. And once one's inside computing things, you don't need units. In Wolfram Alpha, you need units all the time because you're doing one-shot computations. We've been able to get away without having hierarchical entities for a while, but now that's part of sort of completing things is to get hierarchical entities. So you're saying that this. Can I think of this?
Right. Ultimately, do you see, like, I have a comment: asserted is manifold, and then deduced, and then a bunch of properties. In the entity store, I was hard coding all of those with just a comment saying I deduced these from running the tool, basically. But I would really like for the entity store to just compute those automatically.
Yes.
Using the ontology.
Using what ontology? Using
all of the axioms below. And these are more expressive than just a hierarchy. It's
okay. So
at least in ontology.
So what you're saying is, if we had logic programming like capabilities, you would be able to do this deduction, right? You've got the. I mean, in fact, we could. I'm sure we can do it right now. With you're given a bunch of these relations, and then you're asked for all of these deductions. Well, you need to know. Okay, typically the typical workflow is you are given a bunch of assumptions, and then you're given a deduction that you want to make, and then you find out whether that deduction holds or not. It is typically not the case that you're asked, what are all deductions that hold?
Well, so the typical workflow is you start with a completely blank slate, and I want to start figuring out what properties a space has. And so I could check one property, and that'll mutate.
No, but that one approach is to say there are 100 properties it might have. Let me check every single one of them. Another is more the entailment cone idea, where you just are going sort of forward deduction. Which properties does it now have? You see what I'm saying? Rather than checking one by one and doing theorem proving to find out which ones it has.
And also, like, what's the next most promising one? Things like that.
Maybe, but I mean, to know Okay, look.
I'm saying in practice, that's exactly what I ran into when trying to curate. Was I wanted to know which one of these gives the most information if I were to know the truth value of this property.
Right, but okay. So, okay.
So, okay. I mean, for instance, what the thing you're referring to, Stephen, in logic programming would be encapsulated by something like alpha lean TAP, which is a hybrid theorem prover, proof checker, and theorem explorer, based on mini Canron.
Fair enough. Okay, but I mean, so the question for us is, okay, we've now got examples like these. We've now got examples of, I mean, most of these things in the past, when they are about sort of common sense, people have tried to assemble these big databases of common sense facts about the world. Unfortunately, most of them are rather silly. And, it is remarkable how little we have needed those kinds of things for, for what we do in Wolfram Alpha and things like that. What you're showing here is an example where there is enough depth of kind of properties implying each other that it's worthwhile to have some kind of symbolic programmatic way to approach it.
Also queries like, give me example spaces that have these properties.
No, I get it, but I mean, this is a new thing where we don't have, I mean, like for example, let's imagine species. And unfortunately, Michael had to go, but we, let's imagine species, it lays eggs. That implies this or that. Unfortunately, I think those are much thinner. I mean, this may be our first example of a non-trivial kind of collection of implications that we can then deduce things from. I mean, this is what people imagined, in a previous generation of AI, of expert systems and things like that. People imagined sort of everything was going to be encoded this way, and it wasn't terribly successful.
But, sorry, if I might comment, just both more generally and on connections to the CT framework. So there are two problems here, which kind of Ian has just indicated and perhaps worth discussing separately, right? There's one which is the pure syntactical proof theoretic problem of like, what implication, what can we deduce from the system of implications? And there's also the model theoretic question of, can we generate examples that satisfy this particular collection of properties? And both of those things can be, I wanted to indicate that, so essentially both of these questions can be reasonably nicely addressed with the CT framework as it's currently designed. So, things about like hierarchical data structures are essentially encaptured by forgetful and free functors. So for instance, the fact that every manifold is a topological space, and every topological space is really just a set, is encaptured by the fact that, or encapsulated by the fact that there's a forgetful functor from man to top and a forgetful functor from top to set, and so on. And then you can take the adjoints of that and you can generate a free functor from set to top and a free functor from top to man that generates sort of that creates the freely generated topological space from a given set, or the freely generated manifold, differentiable manifold from a given topological space or something. And then these kind of more complicated operations involving unions, intersections, or ands and ors are encapsulated by limits and co-limits, or special cases of limits and co-limits in the corresponding categories. And the nice thing about that is it both handles the proof theoretic case, because internally everything is just converted to equational logic and it's treated as an ordinary theorem proving problem. But it also handles the model theoretic case, because you can then request specific objects that satisfy certain limit and co-limit equations, and essentially generate models on the,
How are those represented? How are the models represented?
Well, the models would just be objects, right? Because if you've got, you've got some subcategory of man that's been generated by a collection of a collection of embedding functors, which is essentially what would happen if you took, the class of differentiable manifolds and then did some complicated set theoretic operations on it to reduce it down to some class of manifolds that satisfy certain properties. And then all you're asking is just give me an enumeration of objects in that category.
But how do you represent those? I mean, the information that Ian has here does not contain, or does it contain?
Well, so can you do needs of pure math?
Yeah.
So the initialization section above that also has it, if you don't have it installed.
Okay.
and then do random entity of topological space.
Topological space type?
No, just topological space.
Why isn't it in the autocomplete?
The autocomplete is an actual Wolfram Alpha thing. Yep, and then do the property input form summary grid.
And wait a minute.
No, the string input form summary grid is a property of that entity. So you define the set of elements, which is in this case just the reals. Then you define the topology on it.
Okay.
And these are just symbolic representations of the topology in terms of other definitions that are also curated.
You know, I mean, I don't know. But it seems like this is good, actual concrete stuff for Jonathan's category theory framework to operate on. Am I missing something, or is that the case?
Well, so my point was all of these like relationships, like manifold implies, whatever. I'm not actually like proving that in any way from this representation here. This representation is just symbolic. We can format it in traditional form, but I was just checking I was proving them myself with pen and paper, and then storing in a table somewhere. Manifold is true for this entity. I was using that graph to help me figure out all of the truth values.
I understand, but what I'm saying is
actually proving from like basically those representations in terms of like set builder and stuff. That's another that's even another interesting application of the category theory framework.
Right. And so my point is simply that both cases could be handled, right? So in the first instance, I don't think it would be too difficult to translate what's been done here, because in a sense, all that one would be doing would be you generate a purely symbolic sort of version of say top, and then you just assert that essentially a certain class of functors exists that lets you construct from that particular subcategories. And then, and so then in a sense that all of that could be generated just purely from the information that's available here. Mm-hmm. And then the step after that would be to say, okay, then can I provide enough additional equational properties to then be able to not just, assert that such a functor exists, but actually generate it and prove that it's, that it exists and is unique or whatever. Mm-hmm. I agree that's a separate and more difficult problem. But
and by the way, we have symbolic representation, a symbolic representation of top and of a category and of sets in this project.
Then most of what we need is already there.
Okay, so I've got a question. That just in terms of thinking about how to, what other mathematical structures other than category theory are sort of competitors for how to represent all of this stuff? I mean, this sort of meta information about, well, I don't know what can you, I mean, something like Lean or the MetaMath database are somehow an alternative way to store this kind of knowledge. Is that a fair statement or not?
Like Mathlib, sure, except they have more information because they have proofs, which this project.
I see. So this is mere assertions. Just
for definitions, I have the actual, like, if you want to call it the implementation, like for Hausdorff, you can look up and it gives actual conditions for that represent a space being Hausdorff. But for theorems, we just have the statement of the theorem.
Okay, so this is why Jonathan is talking about this. So what this is this is what is true, but not why it is true, mostly.
For theorems, yeah. This is a topological space, so I actually define the set of open sets here.
Okay, but then with respect to FindEquational, well, what are we talking about here?
Well, it's important to note that in Lean and in MetaMath, just as in all practical theorem proving systems, there are different levels of proof, right? Like, so you can do theorem proving at essentially the sort of effective theory level, right? Where you could put in a collection of implications and then prove stuff like that. And a lot of the stuff that's formalized in Lean, for instance, is of that character, right? It's not going down to base level axioms. It's proving stuff based on some higher level set of assertions. There are also some arguments that go down, to underlying axioms of set theory or topology or something. And I think it's important.
Well, I mean, I guess, in like that, for instance, in wherever it is, if I pull up my efforts here with wherever it is, like this is a representation of Euclid without any statements about proofs. It's just says things like these are the propositions in Euclid that are needed to prove such and such a thing, but it isn't saying how that proof works. Is that the analogy to what you're showing here? You're showing this and this property implies this and this thing. I think it's the analogy to this. And this is what, you can, like that, that's the sort of effective level.
Yeah, so I think that the out components of the graph and the Euclid project and also topological properties are both examples of ontologies.
Yes, but this is the detailed kind of theorem prover level version of this. I mean, in this particular case, a lot more detail.
Even in that graph, you still don't have a proof anywhere. These are just.
No, this one here is a proof.
Just links between.
No, this one here is a proof. This is this unraveled into an actual proof of that conclusion. This is merely a statement of what's true. This is the proof. So you're saying what you've got.
I don't think that's true. I think these are both just dependency graphs with different levels of resolution, but they're still only dependency graphs of proofs.
I see what you're saying. You're right, actually. You're right. I have another example somewhere which actually shows the thing with all its variables. Proof functions
in geometry
for this particular case, because there's an equational version of that, right? So, okay.
So it may be worth mentioning that precisely the thing that we're discussing here is the distinction between synthetic and non-synthetic mathematics. So in this duality between logic, category theory, and type theory, what in type theory would be a sort of domain-specific embedded programming language, and in logic would be a kind of higher level proof calculus. In category theory would be what is called synthetic mathematics, like where you're reasoning about mathematical structures at the level of topological spaces or something, rather than at the level of set elements.
Makes sense. Well, I mean, sorry, that's the thing that you're calling synthetic, as in it is a higher level that is like the effective field theory.
This is just standard logic terminology.
No, I understand.
So yeah, so in synthetic, so like, if you wanted to prove theorems in Euclid, you could do it by reducing it to Tarski's axioms and doing first order logic theorem proving, right? That would be the conventional way. But there's also the synthetic approach where you say, actually, let me produce a set of axioms that are directly at the level of, geometrical structures and prove things at that higher level of abstraction. And that's the synthetic approach. And so in a sense, the stuff that's in the entity store right now is potentially suitable for a synthetic theorem proving approach, but not suitable for a kind of, for a non-synthetic atomistic.
Well, but you're saying that we might still be able to use the same equational logic theorem proving at the synthetic level.
Oh, absolutely. I mean, like, obviously it can prove first order implications, and in principle you could program in all of those implicatory dependencies as axioms and then prove stuff from that.
So you're claiming that Ian wouldn't have to use pen and paper, that he should be able to use essentially the theorem prover to do the implications in that graph.
So I think that's not quite right. I think that what the graph is doing is what he's calling the synthetic reasoning, like where I'm giving manifold curve, I'm giving these high level things and then following consequences from that.
And so Ian, am I right in saying that the thing you used pen and paper for was primarily in constructing this set of implications rather than in deducing their consequences?
That was actually like, I have a concrete definition of the Sorgen-Frey line, and it's like not some finite object, right? It's it like treat it like I'm doing a homework assignment, like prove is the Sorgenfleury line this property or not. So that's like the non-synthetic thing. You have to have a concrete object that you're working with and checking the properties of.
Right.
I'm gonna have
that is what, like
I'm gonna have to go. I think
I just have theorem statements, so I can't do that part.
Okay, this is a very interesting topic. It wasn't what I was expecting in this meeting. I would encourage Jonathan and Ian to talk about this, and
happy to.
And possibly James and Nick will also be relevant to this. And let's see whether, whether this is concrete raw material for Jonathan's stuff. And I perhaps Tony is also relevant in terms of the hierarchical entity business. I mean, if it's going to be the case that we're going to wind up with statements like this about hierarchical entities, like animals with fur and stuff like this, which we've never made use of really before, but maybe finally we are actually getting to the point where we can use these things, then we should look at this.
Yeah, I will check with Michael and Tony about it. Go over what we went over here and see what they think.
Sounds good. All right, we need to wrap up here. Okay. See you guys.